In this video, we'll talk about how to simplify complex fractions. If you have a complex fraction that consists of a single fraction being divided by another single fraction, you can follow these steps. We'll perform the indicated division by multiplying the numerator of the complex fraction by the reciprocal of the denominator of the complex fraction. So it's a lot like the keep, change, flip we've done before. And finally, you'll use factoring if possible to simplify your final answer. So I can see that x minus 8 divided by x squared minus 16 is a single fraction, and that is divided by x squared minus 64 divided by x plus 4. That is another single fraction. So the way we're going to break this apart is we're going to keep the original numerator of x minus 8 divided by x squared minus 16, and we'll multiply that by the reciprocal of our denominator. So now x plus 4 will become the numerator, and our denominator is x squared minus 64. So it's pretty much keep the numerator, change division to multiplication, and then flip your denominator. Now we would look for any possible opportunities to factor. X minus 8 is already completely factored. However, x squared minus 16, that's a difference of squares. So the way that's going to factor is into two different binomials. That would be x times x to make our x squared, and 16, remember, is 4 times 4. In order for the middle term to eliminate, you need one binomial with plus and one with subtraction. So we have a new way to write that binomial in its factored form. In our next rational expression, x plus 4 is completely factored already. X squared minus 64, again, that's a difference of squares. So we're going to factor into two binomials. X squared comes from x times x. 64 would be 8 times 8. In order for the middle term to be eliminated, we need one binomial with plus and one with minus. So that's the new way or factored way to write that difference of squares. Now we would look in the numerator with our quantity of x minus 8 and see if we have any identical factors in this denominator. So x plus 4 is not a match, x minus 4 not a match, x plus 8, nope, x minus 8, here we go. So we have two identical factors to reduce. Now we're looking at our numerator x plus 4, and in the denominator I can see there's another identical quantity. Remember, what happens when I'm crossing these out is they're not disappearing, they are reducing to 1. And quantity x minus 8, that reduced to 1. So anything that I haven't crossed out, I'm going to highlight. 1 is multiplied by 1 for the numerator. Quantity of x minus 4 multiplied by quantity x plus 8. So our final solution here is going to be 1 times 1, which is 1 in the numerator, quantity x minus 4 multiplied by quantity x plus 8 in the denominator. So this is our final answer. In example 2, we do not have a single fraction in this numerator. We have two separate fractions with addition, and in the denominator, we have two separate fractions with subtraction. So the steps to follow here are to multiply the numerator and the denominator of this complex fraction by the lowest common denominator of the fractions in both the numerator and denominator. And then we'll look for factoring to reduce if possible. So in other words, we're looking at x and y and x and y. We have four different denominators in this problem. So if you recall, the lowest common denominator is the product of each unique factor to its highest power. So one factor is x. Another unique factor is y. Another factor is x. Notice we already have x. Our last factor is y. Again, we already have y. So let's go back and compare our factors of x, and we can see that both are written with an exponent of 1, and both bases of y are written with exponent of 1. So our lowest common denominator is xy. This means that all 4 of these terms need to be multiplied by our lowest common denominator of xy. Multiply every term by xy, being careful how to line up xy. It lines up with the numerator of our fractions. So some of you might like to write that as division of 1 to help you track it. Again, starting with xy, multiplying by 4 over x for the denominator, minus x times y times our last fraction, 5 over y. If you want to write division of 1 to help you track this better, you can do that. Now we're looking for any opportunity to reduce. I can see that x reduces with x in that denominator, and then y reduces with y. In the denominator of our complex fraction, x reduces with x, and y reduces with y. Now what should happen is that fractions within the numerator should be eliminated, and fractions within the denominator should be eliminated. What we have remaining in our numerator is y multiplied by 2 added to x multiplied by 3. So that would be 2y plus 3x. In our denominator, we have 4y minus 5x. Now, comparing 2y plus 3x, 2 and 3 would not have a common factor. Y and x are different variables, so there's no greatest common factor to try to factor this anymore. The same is true with 4y minus 5x. 4 and 5 would not have a common factor. Y and x don't have a common factor, so this would be our completely factored answer. In our last problem today, you can see again, because we've got addition and a lot of addition happening here in the denominator, we do not have single fraction divided by a single fraction. So we will need to come up with a lowest common denominator. In our numerator, we have x plus 2 as a factor and x minus 7. So those obviously are different factors, so that is going to be used to help us build our lowest common denominator. They are unique factors, so we need each of those factors. Now our denominator is not even factored, it's a trinomial. So we know that it will need to be factored. Again, you might be able to use one of the known factors for factoring a little quicker with this trinomial. I know that x squared can only come from x times x. 14 is our product, 1 times 14 or 2 times 7. Thinking about our sum, 1 and 14 will not make 9, but 2 and 7 would. So maybe the symbols needed here need to match the plus that we find in the middle. Also, now these factors are already the same factors as what we have from our other denominator. So when we factor x squared plus 9x plus 14, it will factor into the binomials quantity x plus 2 times quantity x plus 7. So it looks like we already have identical factors in our lowest common denominator. So what we're going to do is multiply all of the terms in the numerator by these two quantities. So I'm going to have x plus 2 times quantity x plus 7 multiplied by my first fraction of 2 over quantity x plus 2 added to quantity x plus 2 times quantity x plus 7 times 6 over the quantity of x plus 7. Now that's just the numerator. And in the denominator, we need our LCD, quantity x plus 2 times quantity x plus 7 multiplied by our fraction. And do be sure to use your factored form. So 4x plus 13 is divided by quantity x plus 2 times quantity x plus 7. What should happen is, with reducing, our fractions within the numerator and denominator should be eliminated. With our first term, you can see the quantity of x plus 2 is reduced, and now we are not going to be left with a fraction. For the second term, quantity x plus 7 is reducing. Again, we are left with no fraction there. Within our denominator, both quantity of x plus 2 and quantity of x plus 7 reduce, and you can see we are not left with a fraction. So what we do have remaining in our numerator is 2 is distributed to this quantity of x plus 7. That would be 2x plus 14. Here we have 6 being distributed, so that leaves us positive 6x plus 12. In our denominator, we have the term 4x plus 13 remaining. You may notice now that we do have some like terms to combine in our numerator. 2x plus 6x would make 8x. 14 plus 12 would be 26. In our denominator, we have still 4x plus 13. So we're wondering, really, is there any factoring possible to help us reduce to get to a final answer? 8 and 26 are both even numbers, so you might be able to at least factor out a 2, leaving 4x plus 13. In our denominator, I'm left with 4x plus 13, and we notice that this quantity of 4x plus 13 is identical. So our final answer is 2.